Good morning, everyone. Um, Welcome to today's talk. I will start with a disclaimer. Hello? Better? Thank you. Um, this is not a technical talk. So today I would like to introduce you to the world of supply chain cybersecurity. And most likely, you already are very well aware. Still not clear? Okay. Most likely, you are very well aware of the importance of supply chain and how to secure it. But my goal today is to get some key messages across in 42 slides. Um, that's an aspirational goal, so let's see if we can meet it. And you can let me know at the end of the talk if that did happen. A little bit about myself. I'm the Director of Supply Chain Cybersecurity at Johnson Controls. Um, I come from an engineering background, so I started as a programmer, moved into network services, and then very focused in information security. So over a span of a couple of decades, I have grown through multiple technology roles to land at where I am today. Um, in addition to that, I also teach. I'm an adjunct instructor. I teach in a graduate program, leading organizations in the age of AI. The last few years that I've been teaching this course, my content has never been the same. Why is that? Because this technology is changing on an ongoing basis. And that's what I would like to highlight today is what is it that we are really looking at with this change that we are experiencing in how we behave with our own environment. In addition to that, I am also the president of Women in Cybersecurity Chicago chapter, and I'm also transitioning into a new role, which is going to be leading the AI affiliate for Women in Cybersecurity. So hopefully that's a really good way for me to give back to the community. I really like it, and if you have not heard about that organization, please join us. We do have a table out there. So today, I'm going to start with some basics, lay the foundation, and then branch into how we actually understand what are the risks of AI in this context, and then how we address those risks with some key takeaways in the end. As I said, a very aspirational goal. Each and every one of those cells that are listed in here, in my opinion, can be a course over a span of 6 months at least. So bear with me. So there are usually some key triggers that tend to bring attention to topics most cybersecurity folks or most even technology folks already think are important and critical. Supply chain security happens to be one of those. But most of the times, your organizations likely did not even take it seriously, even though you were probably screaming about it. But something like a SolarWinds attack really brought that to the center of attention, not just in most of organizations, but actually center of the debate at the government level. This attack that happened on an IT performance management tool that further impacted at least 18,000 customers, and potentially we will never ever know what the impact of this attack was, or how much data was exfiltrated from these, including government agencies. But what it brings up front is an attacker, three things in here. An attacker could gain access. That's your basic foundation as cybersecurity professionals. What are we doing about that? The next one was they could stay in your environment undetected for over a year, and then could push packages out to your customers without validating that indeed that is what you're pushing. That's what your programmers actually were intending to push to your customer. So there were multiple failures. Not exactly technology failures. I think this is process failure. So I already just mentioned, right, like cybersecurity, there are a lot of elements that need to come in, and understanding what are the critical pathways of how you can be compromised happens to be one of those. In between, in the spirit of the conference, I'm going to add some quotes from one of my favorite aliens, just to make sure that you're awake and just kind of, just wake you all up a little bit. So let's start with the what. What are we going to talk about? We're talking about how to secure a software supply chain. brings you to the first and foremost question. What does a supply chain even look like? What does the software look like? So at the basic level, we are looking at software programs, code that is being created. Then you are going to build it, resulting in some binaries, resulting in some artifacts that you're going to then deploy. Very simple way to represent it, but once you start putting multiple pieces of this together, it's a very, very complex engine. And our world runs on software. We buy software, we sell software. So the number of dependencies in the software is multiple levels down. So even though it looks like a very, very simple flow, in reality, it gets complicated very, very quickly. So what happens? What exactly is a supply chain attack, and how does that differentiate compared to other attacks? There is a nuance to this. A threat actor has to access the software and edit your software with the intent to impact a target that is further up the chain. You likely are not the target. Typically, those who are exploited for a supply chain attack don't tend to be the real targets. The real targets are something very different. So with that in mind, let's look at what are the different ways these threats play out. You just looked at the flow of how software is delivered. There is the build process, there is the development process, deployment. At any point in time during that life cycle of delivering software to your customer, you will have multiple threats built in. It is very important that you understand who is submitting or who is making changes to your code, who is building the code, who is validating the code, what technologies are being used, who has access to the build environment, who has access to the tooling, who has access to the verification systems. How are you making sure your artifacts are being delivered securely? Who is signing them? Each and every one of those line items is in and of itself a threat. And you need to be cognizant of ensuring, who is accessing this and who is making all the changes. So integrity is a key element here. Let's start with some numbers, because numbers tend to speak for themselves. The Digital Forensic Research Lab at Atlantic Council tends to track supply chain attacks, has been doing that for a decade now. You'll start seeing a pattern here. Supply chain attacks are not really that commonly tracked under that category. So this lab has been doing a really good job, has been collecting the data and anchoring the data with additional details. As you can see, the pattern has been continuously increasing. To me, 2023 is an anomaly. Not sure why they dipped that much. I would actually expect it to be the other way around. But that aside, the number of attacks are increasing. Now, an attack is actually a validation, a proof that somebody has been compromised. But there are a fair number of vulnerabilities that you will yourself detect and you will report. So that is a nuance between those two different colors you see. There's an attack, there's a disclosure. If you are disclosing something or a retailer is disclosing something on your behalf, then you recognize that it could potentially turn into an attack vector. Why am I bringing this number up? When you start probing deep into that data set, you start digging into the distribution vector. Remember, the supply chain attack is change of your code, compromise of your code to inject something malicious. So the distribution vector is very, very important to understand how this attack will play out. The top two scenarios in here are related to open source category, and then the next one is around supply chain service provider. We're going to zero in on those two in the next few slides. So how is open source even compromised? IEEE did a really good paper on this, and I thought it was really relevant for our conversation today. Open source software can be compromised through multiple conduits, but they came up with 6 different first node attack vectors in an attack chain. Essentially, the package you are pushing to your customer can be developed. They can develop a malicious package comparable to yours and then push it out in the market under your name. You can create name confusion with the legitimate package. We're going to see an example of that soon. You can inject specific sources into that package. That's comparable to something in SolarWinds, even though it was not open source. That's exactly what the threat actor did, inject malicious code. So there are multiple ways of this playing out, but 100 plus vectors, that is a lot for any cybersecurity professional to track. Sorry, there's a switcheroo in my slides. So how ubiquitous is open source? If that is one of your primary attack vectors for a supply chain attack, how much open source do we really use? Synopsys does an annual survey of how much open source, what is in your code? That is literally what they call it. And 96% of the 1,000 plus code bases that they scanned had open source. Let's put those two numbers together. If the most likely attack vector for your product is an open source dependency, 96% of these code bases are exposed already to a potential supply chain attack. Now, what are you doing about that? That's the key question. And more importantly, I will also question, do you need every piece of third-party dependency that you bring in-house? A lot of times, developers bring something in to test things out, to add things to the code for all good purposes. But can we actually stay away from it? Can we minimize that dependency on a third-party software? How do you go about addressing the threats we just looked at? There are multiple ways of doing that, starting basically even at the software level. Who changes your software? How are you tracking it? How and where do you develop your programs? Who has access to those repos? How many third parties are connecting into those systems? How is scanning working out? How are you testing that code during development itself for any vulnerability, any exposure? Moving on, you have to look at your build pipeline itself. The integrity of that pipeline is key. That also helps you to minimize a potential exposure of malicious code being injected during the binary stages. More importantly, you need to start looking at your dependencies. Remember, it's all about supply chain today. So looking at your dependencies, what is in your product? Supply chain, software bill of materials has become a very hot topic lately. CISA has multiple work streams working on the SBOMs. Why? Because at the end of the day, you want to know what is in your software. What is the ingredient list? And the more dependencies you bring in, your dependency chart tends to start evolving. So understand what you're bringing in-house, track it, and validate each and every one of those packages. You should have the strong discipline in-house to do all of those steps. Managing verification, traceability, provenance become essential in this conversation. And also making sure when you're deploying, you're tracking your deployments. You are giving limited access to production environment. You're mirroring your deployment environment to make sure you can actually address potential issues that might show up. So there are multiple ways you can secure the software supply chain. What I have up here are just a handful of things. There is an exhaustive amount of steps you can take depending upon the industry you are in, the type of product you're creating, what your inputs and outputs are going to look like. Now, it's not just us. If you are very familiar with the DevSecOps infinity diagram, that is your really good practice. In the industry, there are enough sources out there, everything from NIST to BSIM, multiple frameworks in place. Now, Department of Defense published this. So NIST actually has 3-part guidelines for developers, for suppliers, developers, and consumers of software to how to secure your entire software supply chain. And this actually comes from that. What's interesting is this is from 2021. Now, let's fast forward just a tad bit. What happened in the fall of 2022? We, as a human society, became aware of something called ChatGPT. Most of you in the tech world probably already knew about generative AI, but the world became aware of ChatGPT. What happened? Overnight, you had 1 million plus developers, lawyers, artists, you name it. Everyone was an expert. Everyone could come up with a solution, maybe an incorrect solution, but you had now a real risk in your environment of someone showing up and introducing, potentially, something that is malicious or incorrect even in the code base. Now, is that easy to solve? The reality is no. AI is messy. I think Ira earlier mentioned AI is a math, is actually mathematical. I agree with that. The real definition of artificial intelligence is it's an area of computer science that is focused on creating products that mimic human behavior, right? Products that react and act like humans, think and act. So if you are looking through that lens, you are really looking at algorithms. At the end of the day, what you're looking at is algorithms. And as this mind map shows, I really love this. I bring it up in a lot of my presentations. It's complicated. It's not easy. It is an area of science in and of itself. So just because ChatGPT became a buzzword and everyone started becoming a developer or name it, you name that specialization, it is not easy to just get into. It's not impossible, but you need to understand what you're trying to get into. Now, one more report that really brings this to point is, Stanford has a human-centered AI group, an institution that actually pushes a lot of research. They also develop a report on an annual basis. And according to them, they were doing some certain surveys about the biggest barrier to entry on scaling anything you are going to do with AI in your environment is through the managing the AI-related risk. Most leadership thinks they cannot control this risk, which is why they will not scale beyond a basic project that was utilizing artificial intelligence. That's your biggest concern coming from senior leaders. Now, that's 50%. So your AI projects are being set up to failure because you have risks in that technology area. What are those risks? Let's look at the highest one, cybersecurity. About 59% of those respondents think securing AI applications is the biggest barrier to pushing AI products in the market. And now, the next one is regulatory compliance. Put them together. That's your typical cybersecurity organization. So now you are becoming, or security is being perceived as the blocker to innovation, as the blocker to revenue generation. So how do we start unblocking ourselves and also now facilitate and help the business do what they're here for, generate revenue? Let's focus on how we actually utilize AI. You might think you're not doing AI because you're not producing AI. Fair enough. But you are probably in the middle sector. You are consuming AI applications. You have been doing that for at least 2 decades now. If you have done any kind of predictive analysis in your environment, if you use Microsoft, Office 365, if you use something like a GitHub, everything in the back end is utilizing machine learning. Maybe not artificial intelligence, maybe not fully autonomous, but at least it's using machine learning. And it's been around for a really, really long time. Now, the next element where you likely are using is around tooling as well. If any of you are using EDR, any of you are doing any kind of software composition analysis, guess what all those tools do? They are using machine learning in the back end to able to scale out and actually deliver the results. And then comes the last one. Are you producing an AI-based product? Maybe you are, maybe you're not. But that's where we're going to focus now is how do you actually secure each of those? So let's start again at the supply chain. What is an AI software supply chain? Remember, I had shared a picture just to start off the conversation around source code, build pipelines, and then deployment. What does that mean in this context? How is it truly different. So AI is, a lot of times people will argue with me, AI is just another piece of software. Well, AI to me is a field of computer science. That aside, it is software, but there are differences in the final product. For you to create an AI-based product in addition to your software and the other environment that goes with it, you need fundamentally an algorithm, and then you need the data to train that algorithm. Those are the two fundamental differences of regular software product versus an AI software product. And that is where most of your threats are going to start going to show as well. Now, how does this work? In a typical environment, you would take and create an algorithm, then you would take the data sets and then train that algorithm, keep training it, changing, it's what's called the training weights, to get the expected outcome and making sure you are getting the outcome. You keep fine-tuning it over a period of time. It is super hard to find the data, to come up with the right algorithm, to keep training it, to get the outcome you expect with the minimal failure rate that you have set as a metric for yourself. How do we avoid this? We go back to that modular nature of technology again. You bring in-house other models, or maybe you already develop your own model, but you utilize different models, change the training weights, and now you start utilizing it in a different context itself. That's called transfer learning. So you're going to have a model that is learned, that is learning from data, and then you're going to adjust the weights to land at the outcome. And because it is computationally very intensive, you're going to go back and start modularizing this, start utilizing different models. And that's where the nuances start building up. When I said you're going to bring a different model to train your model or to just start from a different perspective, look at this layout. Linux Foundation has an AI and data project. Their mission is to facilitate open source conversations. So they really are investing efforts to innovate AI, to push AI products in the society even. They call it carts. 365 of these is what they are managing today. It has roughly market potential of 13 trillion. Trillion with a T, around 365 such sources. Each and every one of those touches a different process step in your build, deployment, as well as training of your AI product. So hopefully this starts anchoring down that AI supply chain in and of itself can become more complex. How you source data, how do you source your model, how do you create it is complex, and you need to start getting some arms around it. So great, now we know that there is a lot of dependencies. We already knew that from our previous software experiences, but AI is adding multiple different levels of dependencies. Is it all doom and gloom? I do not think so. In my opinion, there are multiple threats, but that's what we do. We actually address the threats. We mitigate them, and if we cannot mitigate them, we try to isolate and make sure you transfer that threat to something else, right? So look at it. So the two key ones in here are going to be the data and the model. That's new compared to your previous software supply chain. Anything related to data poisoning, correcting the logic, and then coming to the model itself. A smart threat actor can inverse the logic of your model because the model is continuously learning from the data and the inputs that you're providing. Now, bear in mind, models in and of themselves, there are too many versions of that. I'm simplifying it over here. But there are supervised learning models, unsupervised learning models, multiple types. So at a simplistic level, a threat actor can learn from your model and can actually inverse the logic of your model and potentially steal the IP because now they understand how that model works. So those two vectors are very different compared to what we have been seeing so far. The other ones, whether it is the operations, the design, the infrastructure, comparable. You still have to do the right things. You still have to have the right training platform in place. You still need to make sure your code is correct. I mentioned ChatGPT and potential to create code. Do you know that GitHub has a Copilot where you can actually create code? And GitHub did this survey again a year or two ago. They asked 2,000 developers how much time did they use to develop code through Copilot versus what they would do in a normal time period. So when they used Copilot, for that project, it was down to 56 minutes, compared to 161 minutes where they had to do it on their own. 56% improvement in productivity. Now, if you can go back to your organization and help your developers improve productivity by 56%, would you not do it? Would your leadership not take that opportunity for it? So there are enough organizations right now that are utilizing AI-based code generation. But bear in mind, it comes with an additional amount of risk. And that is what you need to make sure you have the guardrails in place to track. And I cannot reiterate enough about shadow AI. As I said, you think you do not have any AI products? Question it, probe it. You have enough shadow AI happening around you. Maybe you do not approve GitHub Copilot, but I bet you your developer team probably already knows how to go create code or question and say, here's my piece of code, find any faults in it. Maybe they're doing it through a large language model already, regardless of what your policies are. So there is enough shadow AI happening in our environment today, and it will continue to grow. MITRE has a very, very good attack layout. So there is a series of tactics and techniques that a malicious attacker would have to go through to exploit a machine learning algorithm. As you can see, there are way too many techniques in here, and you need to be aware of each of these. What is fundamental is you actually need to train your development team to understand what this looks like. How can a machine learning model be compromised? How can your data set be poisoned? What is a different attack vector? And what are you going to do about it during the design stage itself to address each of these techniques? And interestingly, I've been tracking this for at least 3 to 4 years now, and that has changed. They have added the machine learning attack staging as one of the other tactics that was relatively new as well. So, are there really attacks happening for machine learning models? Absolutely. Here are some of the examples. And I'm going even before, intentionally, so before ChatGPT even came in the purview of our interest. Proofpoint evasion. Proofpoint is an email filtering tool. And so researchers were able to evade Proofpoint's protection system and create a copycat model, fine-tune it, and then be able to craft malicious emails. How does an email filtering system work? You receive spam, it receives a score, it's lower the score, it's marked as spam, higher the score, it is approved as an email that should be delivered. So the researchers in this case could figure out how Proofpoint's machine learning model worked. They created the model, a copycat model, and now they started sending emails, crafting emails that would get the higher score. And now you're sending spam. Phishing link is the biggest threat. I think yesterday someone mentioned phishing still continues to be one of the biggest ones. This is one of the best ways to actually overcome that, right? You craft your phishing emails in a manner that evades the email filtering platform. So there is a CVE that was published, and Proofpoint actually accepted that and they addressed that. Now, more recently, there was a virus total compromise. This was truly poisoning the machine learning supply chain. There was a report, McAfee got multiple reports of a ransomware family was being submitted to virus total. Now, samples of that ransomware family were different. They were comparable, but very different. Turns out these were all mutants of the same ransomware, and the attacker had utilized one of the tools called MetaMe to create multiple variants. And now what happened was, at the end of the day, they poisoned the data set for that ransomware family. Because not every one of these variants was an executable, you could not tell What you're getting in could be an impactful executable or not. You're not just totally poisoning the very basic of your tooling, your scanning tooling. That comes the PyTorch dependency. This was, the Linux packages for PyTorch was compromised by uploading a binary with the same name. Now, because the PyPy package manager, I call it the pip, sorry, I was trying to get to the full form here. The PyPy package manager takes precedence when you're pushing packages. That malicious package was installed rather than the legitimate one. Your classic supply chain attack. Remember, I started with that definition. Malicious code being pushed to a target. And in this case, the targets were about a few thousand customers who had updated in the last week of December. Again, the timing makes a difference. These are all updates pushed in the last week of December, and now PyTorch was pushing out communications to, hey, roll back, go back to the older versions. So supply chain attacks are not a thing of future. They're happening right now. They have been happening for years. You likely have not even realized or recognized one of those attacks so far, unless you're deep in that, in that technology in the team. I love this one, so that's just there. So securing this AI, securing the software development life cycle of AI. How do you go about doing something like that? We have added layers of complexity from your basic supply chain to the AI inputs. How do we go about doing it? Let's start with a few things. And each of these, again, is going to be almost a few sessions to even address and even scratch some of the things I'm putting up there. But I do want you to take away. I want that seed to be planted of how you can go back to your organization and actually facilitate the conversations that are needed to secure your AI-based environment. Basics. Absolutely the basics. Starts with the existing foundation. Just because you layered in the fancy term model or data set or training weight does not mean you move away from your existing DevSecOps lifecycle. That still is needed. All of those preventative measures you had in place to manage integrity, to make sure that your code is not changing, your platforms are secure, your access to your build environments and deployment environments are secure, all of that stays. Now, additionally, though, you will need to make sure the production systems, post-training of your models, are also secure. So don't just think about just training the data set, but after you have trained the data set, after you have pushed it out, how are you making sure you're ensuring its security? That's very important to think about. Then there are going to be those AI-specific challenges, right? How do you ensure your data and model is being maintained? Classic CIS control, software asset management, right? In this case, you now have to add in and layer in the model and data management. Are you tracking it as assets? Is anyone tracking your data sets as assets? And are you linking the data you're using to train your model? Ideally, you should be binding your model and the data cryptographically. So there is always going to be that link available to you where something were to be compromised. Now, I have not touched this word so far. There are regulations now in place to make AI explainable. That is also one of the things you can utilize to ensure the explainability of AI, binding the code and the data cryptographically. One key thing, I mentioned SBOM earlier, the model transparency is, again, absolutely needed. Transparency is one of the, again, vectors why from a regulatory perspective, is being pushed back. The black box element of AI is a big hindrance. How do you maintain that transparency? How do you maintain the logic and the reasoning? For that, you do need your provenance documents. You need to maintain your system cards. You make sure you have your SBOMs in place. There is a new term now, AI bomb. So there's actually a work stream. CISA has a Tiger team doing AI bombs. We are discussing on an ongoing basis what goes into it. In an SBOM itself, we are still talking about what are the ingredients of an SBOM. We now have to look at what goes into an AI bomb. How do we go about accounting for the different pieces in an AI system? Metadata lineage. I can't reiterate that enough. If at the end of the day, you're looking at a supply chain, one, you want to make sure it is tamper-proof, and the second, you can verify who is supplying. Those are the two key aspects of ensuring supply chain integrity. So metadata and establishing the lineage of each artifact, and an artifact in this case can be the model, can be a data set, can be your code, your platform. Each and every one of those, you have to track the lineage of it through multiple versions. As the data sets change, as your model changes, as the weights change, each of those should be tracked very, very strongly. And set it up so you can actually query it. You can go deeper into dependency graphs, understand how this works. Not sure if anyone is aware, Log4j in a lot of environments was at a dependency at least 12 level deep. And I'm not talking of your first party or your second party dependency, 12 levels deep. So open source software tends to have that tendency to become the multiple dependencies, the iterative dependency. So having a dependency chart is super helpful. There are frameworks out there that will help you do a lot of this. Now, focus on your third-party inputs. Always ask them to be transparent. Ask them to provide the SBOMs. Make sure you have right tooling in place. Your software composition analysis tools should be automated. Anytime someone brings in a dependency, you should trigger off a test. You should be able to verify and validate. Now, one key one, it's all about resilient systems. How do we make sure the AI product you're creating is resilient to attacks? This actually was published in 2019, probably. So NIST, once they did the AI risk management framework, then published the adversarial machine learning taxonomy. This taxonomy actually goes deeper into how a machine learning model can be compromised and what we can do about it. So they talk about the different types of attacks and what kind of defenses we can build in, and more importantly, every defense comes with a price. The computational price, the delay in going to market price, each and every one of those defenses are something you need to take into account when you are building a resilient system. So this is a really good resource to even start with, your fundamental basic, how to make an AI system resilient, how to actually build resilient systems, not just secure systems. And that should be the key focus. So now that we know what AI does for us and what we can do with AI, how we secured some of the supply chain concerns, how do we actually leverage the technology itself for our use? So as security professionals, most of you will encounter AI. Start embracing it. Don't push back on it. I do not want it in my environment. I do not know what it's doing. Well, learn what your machine learning models do. Learn and understand what your tooling does. If you don't understand, bring the support in, question them, and utilize it. This will help you scale. This is going to help you understand what's going on in your own environment, whether it is doing the vulnerability assessments, whether you're tracing the dependencies, whether you're even doing secure coding. Do not push back. If your developers want to use large language model to do coding, if you say no, guess what's going to happen? They'll go behind your back and they will still do it. So bring in the right guardrails, train them better, and make sure you are involved during those conversations. Saying no is not the way to progress, but you can leverage AI to help you actually to be a better partner to the business and help drive better business results and become the unblocker security, not the blocker security. So how do we go about doing this? I don't know how much. Okay. And when do we do it? At what point in time should you start taking all of these steps into account? You should have probably done it 5 years ago, but we can certainly start right now. So the 3 areas I would like you to walk away with, key things. This is not a security problem. Supply chain attack is not a security problem. Ensuring security of our environment, of our products, is not a security problem. It is a business problem. You cannot do this alone. You need to partner with data scientists. You need to partner with the development team. You need to partner with the IT team to ensure each and every one of those phases of development is secure. So again, I reiterate this. This is not something you should be doing on your own. You should be doing it in partnership, in collaboration with others. Maybe you head it, that's different. Do not do this alone. And bring to the table your leadership. Why? Because you need to know very, very clearly what is the expected outcome. It's easy to put that down if you're doing a very small project, an AI-based project. But when you're pushing to market something that could be, okay, it's going to detect cancer, and you're going to be a healthcare provider who is going to create a machine learning product that you're pushing into the physicians' offices to help them detect a disease. It's now life-threatening, life-saving related issue. So it gets very complicated very quickly. What is that outcome? Be distinctly clear, and then trace your lineage backwards of your system. That's where explainability comes in. That's where your even legal team is going to help support you. Because at the end of the day, regulatory requirements expect you not to be a black box, expect you to explain your AI. And having that outcome and then working backwards is going to be super helpful to do so. Governance is key. Do not push back your risk, and the governance team actually partner with them. Document this very, very clearly. Raise awareness and share. And make sure you have proper metrics in place. What do I mean? Did the model fail at some point? What drove the failure? How are we tracking failures? Where are we bringing the data from? How many models are we bringing in? And when we do bring in the models, where are we bringing them from, and how do we track it? Are these open source models? Are these licensed models? How are you maintaining validity of your products? How are you delivering them? So all of these are different metrics that you can potentially track. You can't track everything. So be very clear with your leadership what they want to see and what is required of your industry from different lenses. Then comes the transparency itself. We keep going back. Model and data are the key differentiators when it compares to your regular software supply chain. And maintaining the transparency is very important, not just for regulatory purposes or your customers, but even for your own team to track what they're doing, how to change data. Your change management process should have all of those documented. So metadata is going to be super helpful. Always document your metadata, catalog it, make it searchable, make it queryable. I talked about AI bomb. Not there yet. It's coming, but it is also going to become something that potentially can become a requirement. In US, software attestation is something that most software producers have to provide to a federal government if you want to do business with them. You likely will have your CEO or maybe even a CISO signing off and attesting that the software that was produced is secure. That is now a requirement. Layer in AI, that becomes that next level of requirement. Anything you're pushing is secure. How do you go about doing that? What complexity does it add? Have you talked to your legal team for some guidance on this? If you have not, then this would be a really good time to pick that up. I cannot reiterate enough about cryptographically binding a model to training. That will really save you as you progress through the cycle. Training models change, data sets change. Your model behavior cannot change, so you make sure which data set you're using to train your model. Clarify and bind it. Risk management. If we have heard something over the last few years, it's all about AI risk. How it impacts our lifestyle, how as a human species we are at risk. But now we are looking at risk within the organization itself and how we can manage those risks. I do not think AI is a terminator, or that artificial general intelligence is going to take over the world. Maybe it will, maybe at least not in my generation, maybe further down. But what it can do is cause a lot of issues, including threats that will compromise your business. The threats can be security-based, or they can be more systemic-based, like introducing bias in your model. So risks are very, very important in this context. You need to make sure you understand the risk, which is why I say this is not a security problem. You can secure the product, but the risks that are coming inherent to how you're building the product and what's being utilized to build the product is something different altogether. So make sure your risk management team is part of the conversation. They are actually looking at how and where you track your data, the privileges to this data, privileged access to your models, to the environment. How are you creating the inventory? Because each and every one of those controls will help you minimize the potential risk in the AI environment. And learn from your mistakes. There will be mistakes. You are likely already making mistakes. Document them, trace them, see your growth, because your models will fail on you. What is important is how you're going to retrain them and what are you learning from those failures. So again, AI, supply chains are prone to attacks, absolutely. We have seen the attacks play out already. A lot of times we're not able to nail down that AI is causing the attack, but it's certainly helping your threat actors become better at it, and it is also exposing you to a lot of vulnerabilities and threats. The focus should be on bringing the right governance in place, and hopefully, just based upon these slides, I planted some seeds in your mind to think through how this develops. Innovation will not be stopped. You should not be the blocker of innovation. Actually, embrace it is my recommendation. Go use AI to see what you can learn from it. Use AI to actually secure your environments, learn more about it, and then make sure your organization embraces it as well. So supply chain attacks, inevitable, already happening. AI supply chain attacks, already happening. What can we do about it? Get smart about it, and actually use AI to minimize those. So thank you all. And I do want to give a disclaimer. Opinions are my own. I'm part of multiple organizations. So these opinions do not represent my employers, present or past, nor do they represent any of the organizations I'm part of. And if I quoted any supplier or product, it's only for reference and as an opinion. I am not endorsing any suppliers. In my role, I perfectly cannot do that, so it's against my policy. So with that, any questions for me? No? That's good. Now, oh, okay.
So I'm a believer that we're in a real hot mess right now with AI, right? I just talked to a lot of customers. I'm in cybersecurity sales. Talked to a lot of customers who are using, AI models, LLMs, and putting data into it. And these are many enterprise CISOs I meet with, and I ask them about how are you firewalling or inspecting the data before it goes into the LLM. You know what the most common comment is that I hear? Oh, we're considering adding something to it. Well, the ship has already left the port, right? The data is already going into the LLM. What do you mean you're thinking about doing something? So I don't know what needs to be done. I'm certainly not an expert in this space, but I'm just concerned, right? That the ship has already sailed, data's already out the door. What are a couple of recommendations that we should be doing? I listened to this, most of it was over my head, so if maybe you could help us as to why maybe some CISOs are a bit maybe late to the game or hesitant about inspecting the data that goes to their LLMs.
Again, there's a lot of tools out there that you can use for data inspection, data tagging, and cleansing. It's a complete vertical in that, the graph I showed for the Linux Foundation. So there are tools out there that are actually doing that for you. So they do not have to ingest data that has not been corrected, the quality checked, and more importantly, has been tested for the context in which they're bringing in. I would recommend going to that card and picking that section and picking some of the tools in there to start utilizing that. And a lot of time, and this has come more in a personal context, people go, my data is already out there. Why do I care to secure? No, data has a shelf life. Your data has a shelf life, whether it's organizational data, whether it's personal data. Your pattern of behavior will change. Your organizational pattern of behavior will change. So it's never too late to start understanding where the data is coming from, cleansing or securing the data. So not all is lost. It's never the case with security. You can always go back to it. Yes, there are going to be instances where there might have been data leakage of PII. I cannot help you there. Your lawyer should be the one you should be talking to. But there are resources there. Please go back to that Linux Foundation card. Open source, that's the intent right there, right? To actually help build that innovation community. And if they're hesitant to embrace AI, it's time they really start coming to these conferences to learn a little bit more about. I just looked at the conference agenda. I don't know how many AI-based conversations we have going on, so they learn a lot. Sure.
First off, thank you for the presentation. Really thought-provoking and helped me a little bit. I want to address this thing about AI. We've been using AI for years. This is not new. So let's bring it down to what we're really talking about. We're talking about large language models and trying to use AI to help the regular user. Please do it. It's great. Now, if you're a CISO and you are concerned that your data is being fed into large language models, you already have a problem that you've been ignoring for years. We've been protecting the data for years. We protect our data. You can't get to it. If you can, it's out there. You've got a regulatory problem. You've got other problems. So let's start thinking about AI in that it's speed of business that we're trying to enable. We're not here to stop that. Large language models are not our enemy. They are our friends. They're going to help me reduce my staffing needs because my people can work faster. My enemies are the same enemies I've always had. It's the adversaries I've been dealing with for years. We just are using, I'm going to change this a little bit, not we. Vendors are using LLMs and large language models to increase the FUD and to scare the crap out of my executive team. And then I have to tell them the world is not ending. The vendor just lied to you. So AI is not the problem. We're just exposing problems we've already had that we haven't taken care of in the past. That's my opinion, only my opinion, and your knowledge may vary.
Bruce, I actually second that opinion. It's just any other technology innovation. Internet happened, cloud has happened. Each and every one of those added additional layers of complexity and threats. AI scale is just larger. Let's acknowledge that. But that does not mean it's a complete show blocker. You really need to understand, and as I said, the more you understand, the better you're going to be at addressing it. So learn about it. Just do not block it from your mind saying, I don't want to deal with AI. Not happening in my world. It's already happening. Just wake up to the reality. Any other questions?
All right, big round of applause for Ms. Shafia Zubair. Thank you so much for your talk on AI survey points.
I do have a question for the audience. Folks, how did I do? Did I do, in those 42 slides, did I get the message across that I had set as a goal for myself? Okay, all right, thank you.